Hello guys, so we are into the last phase of class 10th trigonometry. We have already gone through the basic parts, that is usage of identities, where you guys were facing problems. So I hope that part is alleviated. Now we are going to focus on the miscellaneous problems, because after this also some people will face problems in miscellaneous kind of problem. What is miscellaneous kind of problems? Problems where two identities will be used simultaneously and problems where there will be requirement of algebraic identities, that is a plus b whole square, a square plus 2ab plus b square. This kind of problems will be there in trigonometry, always there, were there during our times, and it is going to continue. So how you are going to attempt this kind of problems, that is where we are going to focus in today's class, and hopefully by today your trigonometry will be strong enough to face the upcoming class 10th board examination. Okay. So coming to miscellaneous problems, MISC problems. So first of all I would name this, these are those problems in which there will be usage of algebraic concepts, that is algebraic identities. So which is our first problem? Our first problem is, so number 1 problem, sec to the power 4a minus tan to the power 4a minus tan to the power 4a is equal to 1 plus 2 tan square a. Okay. So how we are going to solve this problem? Sec to the power 4a minus tan to the power 4a definitely is not a part of the identities that we have done, but we have done sec square a minus tan square a is equal to 1, that part we have done. So this to the power 4 is something I need to eliminate. However, I can clearly see my left hand side. What is my left hand side over here? Sec to the power 4a. That means I can write this as sec square a whole square minus tan square a whole square, correct? Now this forms in the a square minus b square form. So here there is a key concept. So in each problem we solve today, we are going to write down what is the key concept that we are using. So here the key concept is a square minus b square is equal to a minus b, a plus b. This is our key concept over here. Now from here I can easily use sec square a plus tan square a, that is a plus b, because here a is sec square a and b is tan square a. With that I am going to write down sec square a minus tan square a, which definitely many of you guys are already thinking and done it, that this is equal to 1 sir. नेक्स्ट लाइन में लिखना ही नहीं है. नेक्स्ट लाइन इज सेक्स स्क्वायर ए प्लस tan square a. Now I always have to keep my eyes open towards the right hand side. That is why I have always said you, whenever there will be a problem given, do not directly write down LHS. First you write down that proof problem as required to prove. After that proceed, because then the right side will be always visible in your eyes and you can go ahead. This will be, how will you proceed? See, you need only tan square a, you do not need sec square a. So you have to eliminate this sec square a. What is the key concept? Simple, we know the identity 1 plus, this is tan square a is equal to sec square a, right. So this can be written as 1 plus tan square a plus tan square a. So 1 plus 2 tan square a. This will be equal to RHS, right. So pretty easy problem, and each and every one of you can do this one. Just a little bit of application of this formula and you are going to ace this, correct. Coming to our next problem. Next miscellaneous problem based on algebraic identities. Everyone will be able to do all the problems of trigonometry pretty easily if you just follow the steps correctly. Remember, yes, you have to remember certain formulas, otherwise it will be difficult to master the topic. Our next problem is number 2. RTP is sec to the power 6a minus 10 to the power 6a is equal to 1 plus 3 10 square a plus 3 10 to the power 4 a. Nothing to worry, this is a very easy problem. It may look very big, but I am pretty sure you guys are not afraid anymore of bigger problems, because much bigger looking problems actually are very simpler. Okay. So, this one, whenever you see this one, you can understand that, well, I can go by algebraic identities. So, I can easily write this as sec square a whole cube minus 10 square a whole cube, correct? This falls in the formula. What is the key concept? Always write this. Previously, when during our times, it was very much mandatory that whenever I use any formula, I have to write that in the bracket by using this formula. Nowadays, I have seen that many people do not write, but this is actually a good habit, because as many time I write the formula, it gets ingrained in my mind. It helps me do problems in later stage of my life. So, key concept over here is I have this a cube minus b cube formula, that is a minus b, a square plus b square plus ab. So, here we have what is a? Sec square a. See how my eyes are going to lit up, how each and every one of our eyes is going to lit up over here by seeing this again. Everybody must have thought about it. This will be 1. Other part, a square, sec square whole square, that is sec to the power 4 a plus b square, 10 to the power 4 a plus ab, sec square a 10 square a, bracket closed. This part is 1, so I do not have to think about this. I will just think about this one. While I go about this one, I will also definitely see my right hand side, because that is important over here. So, first of all, let me write this again, it will help. How? Sec to the power 4a plus sec square a 10 square a plus 10 to the power 4a. Why do you think I have written this 10 to the power 4a in the right side now? Because I can see this 10 to the power 4a over here, correct? So, definitely this is required at any point of time. I am not going to change this at this now, because I have this 10 to the power 4a, let it remain like that. Let us do the other part. From here I can easily take common sec square a. So, I will get sec square a plus 10 square a, okay, and here 10 to the power 4a, okay. Let it remain like that. Now, what happens? Let us see. Okay. What is sec square? What is sec square? Can I do something with it? Well, I can, I think. Let us go for it. This is 1 plus 10 square a. And what is this? 1 plus 10 square a plus 10 square a. So, 1 plus 2 10 square a plus 10 to the power 4a. Things are falling in place if you see. Now, if I multiply all this, please do it yourself. 1 plus 10 to the power 4a plus 3 10 square a, this will be 2 10 to the power 4a plus tan 4a. Please multiply yourself, you are going to get this result, do not worry. So, this is equal to RHS. Another very tough looking problem can be easily solved by using certain key concepts. That is what my intention is. So, I hope each and every one of you have been able to do this pretty easily, and we can proceed to the next problem. Okay. You will see similar type of problems in your textbook involving cosec 6 theta minus cot 6 theta, similar type of problem. So, that one you can do in any textbook that is there, you can do by yourself. So, we are proceeding to some other type of problem over here, number 3. This is sin cube theta plus cos cube theta plus cos cube theta divided by sin theta plus cos theta plus sin cube theta minus cos cube theta divided by sin theta minus cos theta. Let me check the question again. Yes, it is equal to 2. So, this is required to prove. So, what will be my LHS over here? First of all, I have to go by the LHS, I have to find out. So, by seeing this problem, I can easily understand this is a cube plus b cube and a cube minus b cube formula type problem. So, I can easily write this as sin theta plus cos theta sin square theta plus cos square theta plus this will be minus a cube plus b cube is a plus b, a square minus ab plus b square. ठीक है, प्लस साइन थीटा माइनस कॉस थीटा साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा प्लस साइन थीटा cos theta divided by sin theta minus cos theta. Understood this part? So, what I will do next? I am very much happy with this because I can cancel it out. Now, if you see, you are remaining with over here sin square theta plus cos square theta is equal to 1, 1 minus sin theta cos theta plus 1 plus sin theta cos theta, cancels out, 2. Much simpler than the other one, I think. This is a much simple problem. I will proceed to the next one now. Cosec to the power 4 theta minus cosec square theta. Cosec to the power 4 theta minus cosec square theta. Problem number 4, cosec to the power 4 theta minus cosec square theta is equal to cot to the power 4 theta plus cot square theta. ठीक है? So, how are you going to prove this? How are you going to prove this? Definitely I have to convert all the cosecs to cot, which is a very easy job for me. Actually, this is a very easy problem. If you see this, you can write this as cosec square theta minus 1. Now, the key concept over here is cosec square theta minus cot square theta is equal to 1. So, if you see, I have to go for cot 4 theta, that is all will be cot. So, here it will be cot square theta. in this one, and here cosec square theta is equal to 1 plus cot square theta, correct? Cosec square theta is equal to 1 plus cot square theta. So, 1 plus cot square theta. So, this will be cot square theta plus cot to the power 4 theta. So, as you see, now when we are doing the problems, things are becoming much easier and smoother and definitely faster. Okay? Easy, smooth and fast, and that is what we want our life to be, right? Easy, smooth and fast. Going to the next problem, nice practice session is going on. I will not say this is a learning session, now it is getting converted into a practice session. So, I will take next problem now. Our next problem is, this looks big, 2 sec square theta minus sec 4 theta, okay, minus 2 cosec square theta minus 2 cosec square theta plus cosec 4 theta is equal to cot 4 theta minus tan 4 theta, cot to the power 4 theta minus tan to the power 4 theta. Okay. So, I will go for LHS. First of all, if you see this, from here you can take sec square theta common, you will get 2 minus sec square theta, and from here you can get 2 cosec square theta, sorry, only one cosec square theta common, 2 minus cosec square theta. Now, what is 2 minus sec square theta? So, I will convert this sec square theta into tan square theta. Okay. So, let this sec square theta be as it is right now, and this one will be sec square theta is 1 plus tan square theta. So, this will be minus tan square theta. Cosec square theta will be similarly 2 minus 1 minus cot square theta. Okay. So, now what is this sec square theta? Sec square theta is 1 plus tan square theta, and I have 1 minus tan square theta. How beautiful, right? How beautiful. A plus b, a minus b, a plus b, a minus. Here also will be same, 1 plus cot square theta. See, confidence is rising while you solve the problem like this. So, whenever what happens is, many times what happens, I look at the problem, I get frightened, but when you start doing the problem, things will open up. So, you have to try actually. 1 minus cot square theta. This will be 1 minus tan to the power 4 theta. I hope this can be understood easily now. Minus 1 minus cot to the power 4 theta. 1 minus tan to the power 4 theta minus 1 plus cot to the power 4 theta. Cot to the power 4 theta minus tan to the power 4 theta, that is the RHS. So, just keep doing problems, you are going to get too much interested in this subject, I will say you. You have to keep doing problems. Whatever subject you are feeling that oh nahi ho raha, I will think, I will always say, in fact I will not think, I will say that just keep doing it. Excelling a subject is just like arranged marriage, nothing else, just like arranged marriage. Live it, you will fall in love, and that is fact. You have to live with it. Rather than going away from it, you have to live with it. Okay? You don't have a choice actually. And why to make a choice when you can live with it? Nowadays people are very impatient. Don't be impatient. Be patient. Our next problem is, take the next one, let's take a good one now. Okay, this is nice one, this looks better. So, this I think 7th problem or 6th problem like that. 1 plus cos theta minus sin theta. Sin theta 1 plus cos theta. You have to prove that this is equal to cot theta. Okay, okay, nice. This is sin square theta. So, how I am going to proceed with this problem? See, whenever I see this sin square theta and I also see 1 plus cos theta, and in my right hand side there is only a single term. So, I have to do something so that everything gets cancelled out and I get some simple term. So, how can it be possible? Let us see. See, this is 1 plus cos theta. Why don't you write it in bracket? Because I have this bracket in the denominator also, 1 plus cos theta, and this is minus sin square theta. Does that ring any bell? What is sin square theta? 1 minus cos square theta, correct. 1 plus cos theta, that is one term, minus 1 minus cos square theta divided by sin theta 1 plus cos theta. Now, I think each and every one of you know that from this I can take 1 plus cos theta common, because 1 minus cos square theta is what? 1 plus cos theta, 1 minus cos theta, 1 plus cos theta, 1 minus, a plus b, a minus b, a square minus b square. Chalo. So, this will be 1 plus cos theta common. So, this term will be 1 minus, from here 1 plus cos theta is gone, from here 1 plus cos theta is taken common. So, what is left? I will take a small bar bracket over here, 1 minus cos theta. Okay. In life, whatever you learn, use it wherever possible. Use it wherever possible, so that you can basically revise the concept. Many of you must be thinking, "Arey yaar, bar bracket, I have learnt it in class 7th and 8th. I have not used it for so long." Now you can use it. There is opportunity. Sin theta, and here it is 1 plus cos theta. Something gets cancelled out, makes my life easier. Here it is 1 minus 1 plus cos theta. Wow, so beautiful, so beautiful, cot theta. So nice, nice problem. Key concept is the first identity. The first identity, and another thing, keep your eyes open. Okay. So, next problem. Next problem is very much favorite to me, because once upon a time I asked this to my teacher school. Once upon a time, sometimes in I think 2002 or 2003, I think 2002 it will be, 2002, 2003 January onwards there is no class almost. See, I don't know whether you guys have seen this problem. Definitely you have seen. Minus tan A minus 1 by cos A, okay, is equal to prove 1 by cos A minus 1 by sec A plus tan A. I don't know whether you have faced it or not. What I have faced, I will just discuss that. In this problem, I was told to take this one this side and this one this side. So, it will come out 1 by sec A minus tan A plus 1 by sec A plus tan A is equal to 2 by cos A, and after that prove LHS is equal to RHS. So, it was said to me like that. I am saying what happened with me, I am not saying what has happened with you. So, during that time I was quite surprised, because if I rearrange the given RTP, then many problems I can do that. So, how will I understand whether I should do that or not? So, later on in class 11th and 12th I was going through this problem again, and I found out that this can be done in a way that we do other problems also. This need not be taken to that side and all. There are two ways of doing it. I will show you the easy way, not the tough way. The ones that I learned that time, I think that is not a way. You can do it in a much simpler way. Let us see. Because it has been said you prove LHS is equal to RHS. So, I will be going by the simple and the route that we have been going through all these years. So, first of all I will go for LHS. Whenever I see this LHS, I can easily understand this sec A minus tan A ring some bell inside my head. I can convert this sec A minus tan A to sec square A minus tan square A by multiplying sec A plus tan A in both numerator and denominator. Okay. Minus, this is 1 by cos A, if you see this will be sec A. So, this part, if you see this one, this is sec square A minus tan square A now. So, this denominator is already 1. Sec A plus tan A minus sec A. Answer is tan A. So, now will you say that how will I bring this one? This is complicated, but whatever you have brought, that is simple. Yes, I like that route. I will go for RHS now. It has been said to me to prove LHS is equal to RHS. I am going to do it in this way. I am going to now, I have already simplified LHS, I am going to simplify RHS, and many of you must be thinking, oh, this I should have been doing by myself only. Yes, you please try RHS in the similar way. So, what will happen? This 1 by cos A is sec A minus this denominator I am going to multiply with sec A minus tan A to make it sec square A minus tan square A. So, in the numerator also I am going to multiply sec A minus tan A. Definitely in the denominator I need not write anything, but during your course of doing the problem you are going to do this step. I think the job is done. That is it. Now you can say, so LHS is equal to RHS proved. So, I think with all due respect, if some of you guys have done this problem by taking 1 by cos A to that side and bringing this one to that side, please do not do it like that way. So, in that case it is a wrong number, do not go for that, go for simple route LHS is equal to RHS. Okay. There is a tougher way of doing this problem. I can go for direct conversion to this one also, but I am not going for that. I will just show you how to do this. I will write this one like this. Just see this one. Can I write this? Yes, because this minus this is tan A only. So, I can write this in this way, and after that I am going to convert it into this way, because sec A is 1 by cos A, and here I am going to multiply sec A plus cos tan A in numerator and denominator. It is a tough way, need not go by that, go for LHS, RHS, LHS is equal to RHS, job is done. Believe me, life is simple. Okay. Can we go for the next one? Huh? Life is very simple if you work hard. Smart work is a supplement to hard work. Remember, smart work, the buzzword, right? Nowadays, smart work, you have to work smart, not harder. But remember, smart work is a supplement of hard work. It can never replace hard work. It will never happen. Okay. Anyways, next problem. Sin theta plus cos theta. This is a mixture of complementary angle and a normal algebraic expression type. Sin root 2 sin 90 minus theta. So, here it is said find cot theta. So, how will I go about it? I think it is a very easy problem. See, this is root 2 cos theta. right? This is same. Now I will bring this cos theta to this side. Sin theta by cos theta plus cos theta by cos theta is 1 is equal to root 2. So tan theta is equal to root 2 minus 1. What is cot theta then? Cot theta is reciprocal of tan theta. Root 2 minus 1. 1 by root 2 minus 1. Clear? Now what I will do? I will multiply root 2 plus 1 with both denominator and numerator. Root 2 plus 1 by, this will be 2 minus 1. Root 2 plus 1. This process is called rationalization, right? Hopefully it's okay now. Already we are into the fag end, so we will be solving our last problem after this one, and after that I am going to bid you goodbye and good night, and that will be end of the trigonometry part, the how to prove part, the fag end of the chapter. Complementary angle is easy, so I am not going to cover it. However, if you find that complementary angle you are facing any problems, then you can let me know. I can help out in that one, but I think complementary angles part is much easier. So x is equal to h plus a cos theta, very common problem this one. Next, y is equal to k plus a cos theta. It has been said to eliminate theta. There should not be any theta in your expressions. How I go about it? So we know that cos square theta, I think it will be sin theta, yes. We know cos square theta plus sin square theta is equal to 1. So I am going to use that one. So from here, can I substitute cos theta? Means I can make this cos theta subject of the formula and find out what is the expression for cos theta. So this will be x minus h by a, and similarly this will be, the sin theta will be y minus k by a. Okay. Now if you do cos square theta, you all of us know cos square theta plus sin square theta is equal to 1. Each and everybody of us know. ठीक? So what I will do now? X minus h by a whole square, y minus k by a whole square is equal to 1. So I think that's it. You need not do anything. If something is said to prove, you can go for that, but otherwise theta is already eliminated, so it's done. Okay? In your books sometimes this expression is also there. LCM will be a square only. A square goes to that side, so it's proved. Correct? No problems. I think it is done. I don't think any further problem is there in trigonometry. I think each and every one of us is going to do much better in trigonometry than what it was earlier, and I think I was able to help a little bit in your journey. With that, I thank each and every one of you and wish you all the best for upcoming ICSE and CBSE examinations. Goodbye.